And welcome back, and we're on to the 26th of Feb, higher plus 5 a day. Now, before I zoom in, I can see a big green shape there. I'm wondering what's going to happen. But anyway, let's just go with the first question before we get there. So the first question says work out. So it might say evaluate, it might say work out. It basically just means can you find out what this is in a simplified form. Now, these videos aren't really about explaining all the theory, but hopefully what you'll know is the minus means 1 over, so that's 1 over 27. The third means the cube root, so I'm going to take the cube root, and this 2 means squared. So I can write the whole thing out like this. Now the cube root of 27 is 3, so that's the same as 1 over 3 squared, and 1 over 3 squared is 1 squared over 3 squared, which is 1 over 9, which is my final answer and the first answer today. Well done if you got that. Okay, here we go. What's the green thing about? Calculate an estimate for the rate of change. Oh, it's another gradient question. I don't really like these. And then it says calculate an estimate for the area under the curve. So it gets even worse because now I need to divide it up into different bits. Okay, let's start with the gradient. What I might then do, just to neaten it up, is then delete it and just do the area underneath. Right, what am I doing? X equals 1. So x equals 1 is here. So my best estimate for what the gradient is going to be this line here. And then what I'm going to do is I'm going to do it as far apart as I can and work out point A and point B. Well, point A is going to be, is that minus 2.5? So minus 2.5. What's the scale I've got? So it's going up in halves. So it's more than a half. So let's call it 0.6. Again, doesn't really matter that much. B, probably a bit easier, so it's 4.5, and I'm just going to say that is on the 7, which means my gradient is 7 minus 0.6, divided by 4.5 minus 2.5, get my calculator out, and that's going to be 0.914. Now, that's beautifully accurate, so 0.9 will do, because again, I'm doing it on an iPad. The line's not going to be great. I haven't used a ruler, all the other things that make this slightly inaccurate. But as long as in an exam, and again, I don't know, but somewhere between 0.8 and 1 is probably completely acceptable. Next question. Calculate an estimate for the area under the curve. Now, normally it might say using 4 strips or 3 strips. It might tell you what to do. It doesn't tell me what to do. So I'm going to just divide it up into things that I think look sensible. So I think that this here, it's pretty clearly a triangle, so I'm going to call that area A. Close enough. And actually I probably could have continued that triangle, couldn't I? So I think it then starts to slope around here somewhere, so I'm going to call this a trapezium, and this is B. Now, I could actually do loads of different ones here, but just for the sake of this video, I'm just going to underestimate it massively and call this a trapezium as well. And then I've got this final here. So there's my C and there's my D. Again, if it doesn't say, and it probably always will, if it doesn't say what steps to use or what strip size to use, then just use the ones that fit best. I think my C is not great, but it would do. Okay, so let's write down, we've got A, B, C, D. A goes from 0 to 2.5, so it's a triangle, so it's a half times 2.5 times the height, which is 3. Again, I'm going to very roughly approximate this. B is a trapezium, so it's half the height. So it's a half times 1.5 times the sum of the parallel sides, which is 3 plus, call that 4.25. So 3 plus 4.25. 3 plus 4.25. Being very over accurate there. C goes across by 2. So it's a half times the height, which is 2 times the numbers again, which is 4.25. Must be the same. Plus 3. And D is another triangle, so that's going to be a half times the width, which is 1, times by the height, which I've just worked out, which is 3. I'm going to work all these things out. This first one is 3.75. This next one is 5.4375. Again, being a bit over accurate there, but let's write it down anyway. This next one is 7.25. And this final one is a half, 3 over 2. I'm going to add all this up, and that is going to give me 17.9. Now again, a real exam question should be much clearer as to what it wants you to do, because I've missed a fair chunk of it out here, so it's probably notably more than 17.9, but as an answer it's close enough, and I've kind of got there in terms of how I've done it. I've shown my working. I think if this was literally an exam question, it'd probably allow anything between maybe even 17 and 19 or something, but either way, good question. Make sure you're aware how to do it. Final question today. Not a really big fan of those questions, you might be able to tell. Final question is what's often called a harder rearranging, because the thing that I'm doing, which is the C, appears twice. Okay, so if you've seen any of my videos before, there is, let's not call it steps, but there is a definite way that these questions tend to work. So first step tends to be to multiply through by the denominator. So WA minus CW is equal to AC. Then I'm going to move everything with the C to one side. Now I'm going to move it to the right-hand side because that means it's not going to be a negative. So WA is equal to AC minus CW, but that becomes a plus. Then I'm going to factorise out the C, and you'll see why in a second. So that's going to give me CA plus W. And then I can divide by the thing in the bracket. So WA over A plus W is equal to C. So let's write it nice and neatly over here. So C equals AW. Doesn't actually matter about the order of the letters, but I quite like them to be alphabetical, slightly neater. Either way, it means that C equals AW over A plus W. Question done. Final question. The population of island A is 4 times larger than island B. Okay, so let's try and do this as we go. So population of island A equals 4 times the population of island B. It is expected that every year the population of island A decreases by 5% and the population of island B increases by 5%. Yeah, nice question. After how many years will the population of island B be greater than island A? Okay, now this is one of these questions that's really annoying because you basically just have to try different numbers. When you get to A level, you'll learn this thing called logs, and we can use logs to solve this. So I'm just going to have to try numbers, aren't I? There is a way, it's not cheating, but there is a way of sort of doing it slightly nicely, isn't it? Which is I can say, let the population of island B be 100, and let the population of island A be 4 times that, which is 400. And it just means I can use numbers then. Now, what I'm actually going to do, just so you know, so you don't have to see me do lots of numbers, I'm going to pause the video and just try numbers, see what the answer is going to be, and then show you what I mean. Okay, so I have gone away. In a real exam, you just try different numbers, get to the point. If I use 13, so after 13 years, the population of island B is going to be 100, where it's growing by 5%, times 1.05 to the power of 13, which is equal to, so 100 times 1.05 to the power of 13, which is equal to 188.6 people. After 14 years, well, it's going to be 100 times 1.05 to the 14, which is going to be 197.99 people. So I call it 177.9. So that is 13 years and that is 14 years, just so it's clear. For island A, after 13 years, it's 400 times 0.95. That's my multiplier to decrease 5%. The power of 13, which is 205.3. So you can see I'm comparing the yellow and the yellow, my population of A is still larger. Let's do to the power of 14. So 400 times 0.95 to the power of 14 is equal to, I'm going to just multiply by 0.95, 195.06. So I can now see the green, so here is larger than this. So therefore the answer to my question is after 14 years. Wow, not a bad question at the end. Again, nice sort of clever little twist on a question that is normally just can you increase or decrease something. Good mix of questions again. Well done if you got those. Do let me know how you do in the comments. It's always good to hear these things. And I will see you for the next one. Thanks all.